Airbags have become one of the most essential safety features in modern vehicles, credited with saving over 37,000 lives in the US between 1975 and 2012. Initially introduced in the 1960s as air pillows, airbags were designed to protect passengers during crashes by absorbing the impact and reducing the force on a driver's body. Initially met with skepticism, airbags became widely adopted after regulations mandated their inclusion. By the 1990s, airbags had become a standard feature, and today, over 190 million cars in the US are equipped with them. Their design takes advantage of Newton's second law of motion, ensuring that the airbag absorbs collision impact, protecting occupants from hitting hard surfaces like the dashboard or steering wheel. The mechanics behind airbags are a combination of physics and chemistry. During a collision, an accelerometer detects rapid deceleration, triggering an electrical current to pass through a heating element. This ignites sodium azide, creating nitrogen gas that inflates the airbag at speeds of up to 200 miles per hour. The rapid generation of nitrogen gas is what allows the airbag to expand so quickly, creating a cushion that helps absorb the energy of the collision. The airbag then rapidly deflates through small holes, which helps to absorb the force of impact rather than causing additional injuries by bouncing back. This entire process happens in just 0.04 seconds, giving the airbag enough time to deploy before the occupant's body moves forward. The rapid inflation and controlled deflation of the airbag are critical, as it cushions the impact and distributes the force across a larger area of the body, reducing injuries. The physics behind airbags involve Newton's second law of motion, which states that force equals mass times acceleration. In a car crash, the body is subjected to sudden deceleration, creating immense forces. The airbag mitigates this by providing a controlled deceleration, thus lowering the force acting on the body. Instead of one concentrated area taking the full impact, the airbag spreads the force over a larger portion of the occupant's body, reducing injuries to the chest, head, and neck. Airbags work in tandem with seatbelts, which are crucial in keeping passengers properly positioned for maximum protection. Without a seatbelt, the passenger may not be in the optimal position when the airbag inflates, which could reduce its life-saving potential or even cause injury. Despite their life-saving potential, airbags have had some dangerous flaws. The most notorious example is the Takata airbag recall, the largest in automotive history, affecting over 19 million vehicles. Takata's inflators, containing ammonium nitrate, were prone to degradation in hot and humid climates, causing them to explode with too much force. This resulted in metal shrapnel being propelled toward drivers and passengers, leading to serious injuries and deaths. This defect, caused by poor oversight and environmental factors, highlighted the potential risks of faulty airbag systems. The Takata recall serves as a stark reminder of the importance of rigorous testing and quality control in automotive safety. It led to renewed emphasis on using stable, reliable materials for safety systems. In response to these concerns, automakers have continued to refine airbag technology. Today's airbag systems are smarter, using advanced sensors to determine the severity of a crash and the size and position of the occupant. This information allows airbags to adjust their deployment force, minimizing the risk of injury from the airbag itself. In some vehicles, multi-stage airbags can deploy at different speeds depending on the collision intensity, adding an extra level of protection. Modern vehicles are equipped with not just front airbags but also side, curtain, and knee airbags, designed to protect in different collision scenarios. Side airbags deploy in just 5 to 6 milliseconds, offering rapid protection where there is less crumple zone. These are typically designed to protect the head and torso from intruding structures during side impacts, which can be especially dangerous. Curtain airbags are designed to protect occupants in rollovers or side impact collisions by covering the windows, preventing ejection or injury from shattered glass. Another significant development is inflatable tubular structures, which stay inflated longer to protect against multiple impacts during a single accident. Knee airbags are also a common addition, helping to reduce injuries to the lower extremities by distributing crash forces away from the legs. As vehicles become more autonomous, airbags will have to evolve further. In future self-driving cars, where passengers may face different directions or even recline, airbags must be adapted to offer effective protection regardless of positioning. Airbags have indeed come a long way since their introduction, evolving into an indispensable part of vehicle safety systems. They work together with seatbelts and other safety features to provide a comprehensive system that dramatically improves the odds of surviving a collision. While incidents like the Takata recall show the potential dangers of faulty systems, advances in materials, technology, and quality control have made modern airbags far more reliable and effective. As automotive safety technology evolves, future airbag systems will likely become even better at protecting occupants during all types of collisions, bringing us closer to the goal of reducing traffic fatalities to zero. Thanks for watching. If you enjoyed the video, please like and subscribe to the channel for more content. Stay tuned for more in-depth explorations of automotive technology and safety innovations. See you next time.